All right, going to do some Chapter 7 review here. So again, this is just in the back of Chapter 7, page 361, the review exercises here. This is a really good example of the types of questions that you guys are going to see, not only on the homeworks, but of course on the test, on the Chapter 6 and 7 test. So we'll just kind of go through these in order. I might skip over some of them. This first question isn't really a question that you'll see, but it's interesting to talk about just because of all the definitions here. So here we have this normal distribution, and it gives us a few values on the number line, and then this capital X. This capital X represents a random variable. First thing it's asking is, what is the mu? That's the mean, the population mean. Remember, for these normal distributions, the mean is always right in the middle, so here mu is going to be 60. What is sigma? Sigma is the population standard deviation. Now, they're not super specific about this. I understand the idea they're trying to get across here. Imagining that the 70 is the first standard deviation to the right and the 50 is the first standard deviation to the left, we have gaps of 10 from the mean to these first standard deviations. So our standard deviation, that sigma, is going to be 10. C, suppose that the area under the normal curve to the right of 75 is 0.0668. Provide two interpretations for this area. Okay, so I'm going to go back over, I'm going to go over to my OneNote here and just kind of draw a rough sketch of what we have, a very rough sketch. If 60 is in the middle, that's the mean, 75 would be out here somewhere. What this question is saying is, let's say that we did find the area to the right of 75, and that came out to be 0.0668. What does this 0.0668 mean, or how can we interpret it? And there's two different ways. I mean, there's many ways, but two major ones. The first way is what we did back in Chapter 3. If we think of this random variable as just data points, then what we can say is that the proportion of data points that are bigger or equal to 75 is about 6.68%. Another interpretation that we have now is probability. What we can say is that if we choose a random variable x at random, there is a 6.68% chance that we choose a random variable that's bigger than or equal to 75. So those are our two interpretations. The proportion is 0.0668, or the probability is 0.0668 of being at or above 75. Okay, D is the same thing. Suppose that the area under the curve between 50 and 75 is 0.7745. Provide two interpretations, and it's the same two interpretations, proportion and probability. All right, let's move on to the types of questions that you're definitely going to see on your homeworks, then on the test. So question 2 here. Draw a standard normal curve and shade the area indicated, then find the area of the shaded region. So here it's the area to the left of z equals negative 1.04. So let's go over to our notes here. First thing it does is it says to draw a standard normal distribution. So a standard normal distribution is just a regular bell curve where the mean is 0 and then the standard deviation is 1. These aren't just the regular random variables along the axis here. These are those special z-score random variables. All right, the question's asking us to find the area, I think it was to the left of negative 1.04. So negative 1.04 is going to be just to the left of that first standard deviation to the left. So let's say we're here at negative 1.04, and we want to find the area to the left of that, so this area here. I'm sure if you read through the book, you saw a way to do this using a z-score table, but I don't expect you guys to use that when it comes to working on your homeworks or the test. Just use the calculator. In the calculator, anytime you're trying to find the area in a normal curve, you want to go to second and then the distribution menu, so the second VARS button, and it's the normal CDF. Normal CDF finds area under the normal distribution. Hopefully you have a menu. It's asking for a lower limit, an upper limit, the mean, and the standard deviation. Our area goes to the left forever. That means I'm going to leave my lower limit as negative infinity. This is as close to negative infinity as we can get, so we're just going to leave it like that. This is negative 1 with 99 zeros behind it. My upper limit for my area is the rightmost value of the area, which is that negative 1.04. Oh crap, put that in the wrong spot, jeez. Sorry about that, let me just fix that, put that back. Negative 1.04 here for the upper limit. The mean is next. That's 0 for the standard normal curves. Anytime you're dealing with z-scores, the mean is going to be 0 and the standard deviation is going to be 1, so I'm just going to leave those alone. Paste. If you do not have a menu, you have to type it in just like this, the lower limit, comma, upper limit, comma, mean, comma, standard deviation, and then we get our answer. So that means that that area here is 0.149, or however many decimal places they want you to round on the homeworks. So that's it. That's the answer for number 2 there. The area to the left of negative 1.04, 0.149. Let's look at number 3. All right, so question 3. Still in the standard normal curve, which means the z-score thing, the area between negative 0.34 and 1.03. So negative 0.34 and 1.03. We'll draw our normal curve. Remember, 0 is in the middle for these standard things. Negative 0.34 is going to be very close to 0, just slightly to the left of it. The other one I think was 1.03. 1.03 is going to be just to the right of the first standard deviation. I promise my drawings aren't normally this bad. It's because I'm trying to write on my laptop and it's just hard. So we're trying to find the areas between these two z-scores. So we're looking for this area. I can already tell you it's going to be kind of a big number, but let's figure out what it's going to be. Again, I'm going to use the calculator. Anytime you're finding areas, use the calculator. So second, distributions, the normal CDF option. This time, my lower limit is starting at this negative 0.34. My upper limit is the positive 1.03. We're still talking about z-scores, so the mean 0, standard deviation 1. So my answer, 0.482, if I'm rounding to 3 decimal places. So that's the answer for number 3 there. That's the area between those two z-scores. Okay, 4. With number 4, it's a little bit different. So 4 here, find the z-score such that the area to the right of the z-score is 0.483. So for this one, we're not finding the area under the curve. In fact, we're given the area. For this one, we're trying to find the cutoffs for that area. We're still looking at the standard normal distribution, so the z-score thing with the mean 0, standard deviation 1. But this time, we want to find the z-score such that the area to the right is 0.483. The way this graph works is the whole thing is an area of 1, which means that the halfway mark where the mean is 50, or 0.5. If I want the area to the right to be 0.483, that's very close to 0.5, which means that the z-score I'm looking for is going to be very close to 0, just a little bit to the right of it. This area is 0.483 to the right. What I want to find, though, is I want to find that z-score right there. So this one is backwards from what we were doing in questions 2 and 3. This time I have the area and I'm looking for the z-score. This is where we're going to use, instead of the normal CDF, we're going to use the inverse norm. So inverse norm, and it gives you some things. So first it gives you this area option, and then it has the mean and the standard deviation. Okay, so some of you may have different options here depending on how fancy your calculator is. For my calculator, and for most of yours I'm assuming, it doesn't say which area this is, whether it's the area to the left or the area to the right. If it doesn't say, it's the area to the left, which means that we're not going to plug in the 0.483 into this. We're going to plug in the complement to this. So we're going to do 1 minus 0.483, which is 0.517, because that would be the area to the left of the z-score that I'm trying to find. So 0.517, mean 0, standard deviation 1, paste, and we get our z-score, which remember was supposed to be very close to 0, just a little bit to the right of it, which we have here, 0.04. Remember that you always round z-scores to 2 decimal places. Cool. Let's look at number 5. We'll probably do this one, and then I'll end this video and pick it up in the next video. So number 5 here. Find the z-scores that separate the middle 92% of the data from the area and the tails of the standard normal distribution. So 92%. Again, we would draw our normal distribution. This is still the standard one with z-scores, so the mean is still 0. If I want to find the middle 92%, 92% is a very big chunk, which means that if I look to the left and then the same distance to the right, this area in between is the 92%. There's still 8% left over. And because this is in the middle, that 8% is going to be cut in half. Half of it is going to be in the left tail, 4%. The other half is going to be in the right tail, 4%. Okay. We are trying to figure out what these two z-scores are that cut off these values. So we're going to do the same thing in the calculator. Anytime you know the areas and you're looking for the data values, that's when you want to do the inverse norm option. If I want to find what this z-score is, the area to the left of that z-score is the 4%, so I'm going to put in 0.04. So this z-score is going to be negative 1.75. I don't have to find the other one, because I already know what it's going to be, but just to prove the point, if I do go back into inverse norm, the area to the left of this z-score is going to be the 92% plus the extra 4%, which is 96%. I already know this answer is going to be positive 1.75, but just to show you that it really is, there you go, positive 1.75. I knew it had to be the positive version because it's all symmetric. So if this 92% really is in the middle, then the negative 1.75 and the positive 1.75 have to be the same. But there you go. These are the two z-scores that separate out the middle 92%.